Look up at the winter sky on a crisp, clear night, and you will see it. A brilliant ruby red jewel marking the shoulder of the great hunter, Orion. This is Betelgeuse, one of the most famous and closely watched stars in our entire galaxy. It is a star of myth and legend. For centuries, humanity has gazed up at this crimson beacon, marveling at its steady, colorful glow. But recently, Betelgeuse has been acting very strangely, keeping astronomers on the edge of their seats. The star's behavior has become unpredictable, leading to frantic speculation and intense global study by the scientific community. Betelgeuse is not a normal star. It is a red supergiant, a monstrously huge stellar titan nearing the violent end of its life cycle. If placed in our solar system, it would swallow Mercury, Venus, Earth, and Mars. It is a bloated giant, teetering on the brink of ultimate destruction. Because of its immense size and relatively close distance of roughly 500 light-years away, Betelgeuse is one of the few stars that appear as more than just a point of light in our most powerful telescopes. It presents us with an unprecedented opportunity to study stellar evolution up close. We can actually see its surface, a churning, boiling cauldron of plasma. And we know that this star is running out of fuel. It has exhausted the hydrogen in its core and is now fusing heavier and heavier elements. It is a ticking time bomb, and the clock is counting down. This process is a one-way street to oblivion. Eventually, the core will fuse silicon into iron, a process that robs the star of energy rather than producing it. When that happens, the core will rapidly collapse, and the star will violently explode in a fraction of a second. This explosion, a Type II supernova, will be one of the most spectacular events in human history. But when exactly will it happen? That is the question that has captivated the world, driving both professional astronomers and amateur stargazers into a frenzy of constant observation and debate. The frenzy reached a fever pitch in late 2019. Astronomers around the globe noticed something unprecedented. Betelgeuse was fading. Fast. It was dimming at a rate that shocked everyone who had spent their lives observing the night sky. The great red shoulder of Orion was disappearing. This event, which quickly became known as the Great Dimming, saw the star lose more than two-thirds of its brightness in just a few months. It dropped entirely out of the top 10 brightest stars in the sky. It was an astronomical mystery that demanded an immediate explanation. Speculation ran wild across the internet and in the news. Was the Great Dimming a precursor to the supernova? Was Betelgeuse clearing its throat before the final, cataclysmic scream? The world watched and waited with bated breath, hoping to witness the explosion of a lifetime. Telescopes worldwide pivoted to observe the dying giant. What they found was a complex and fascinating story of stellar physics, rather than an imminent explosion. The truth, it turned out, was less explosive, but far more scientifically intriguing than anyone had initially suspected when the dimming began. Observations revealed that Betelgeuse had blown off a massive piece of its visible surface. This colossal ejection of material moved out into space and quickly cooled. It was a massive stellar exhalation, a dramatic shedding of mass that characterizes the late stages of a red supergiant's tumultuous life. As it cooled, it condensed into a vast cloud of stardust. This dust cloud physically blocked the light from the star's southern hemisphere from reaching Earth, creating the illusion of a dramatically fading star. We were looking at Betelgeuse through a thick, obscuring veil of its own making. It was a stellar burp of unprecedented proportions. A mass ejection so large that it temporarily altered the appearance of one of the sky's most familiar landmarks. It proved that these massive stars can undergo dramatic, visible changes on human timescales, rather than just astronomical ones. But the story didn't end there. After recovering from the Great Dimming, Betelgeuse continued to behave erratically. In 2023, it experienced renewed fluctuations, brightening unexpectedly. It seemed the star was struggling to find balance as its internal furnace sputtered and choked on heavier elements. These ongoing changes suggested that the star's internal dynamics were complex and chaotic, a boiling pot of plasma striving to maintain equilibrium as its primary fuel ran low. The outer layers were undulating, expanding and contracting like a giant heartbeat, driven by the intense heat radiating from the core. Then, in July 2026, a groundbreaking discovery fundamentally changed our understanding of this monster star. Astronomers announced strong evidence for the existence of a companion star. It was a revelation that sent shockwaves through the astronomical community, forcing a rewrite of everything we knew about Betelgeuse. Dubbed Betelgeuse B, this previously unseen companion is believed to be orbiting the red supergiant, gravitationally interacting with its massive extended atmosphere. For centuries, Betelgeuse was thought to be a lone wolf, but now we know it has a partner in its cosmic dance of death. The presence of Betelgeuse B could explain many of the star's recent eccentricities. Its gravitational pull might be stirring up the supergiant's outer layers, contributing to its erratic mass loss rate. The companion could be acting as a gravitational whisk, constantly churning the bloated atmosphere of the primary star. This hidden partner might be the trigger for some of the massive surface ejections we've witnessed. As it plows through the outer envelope of Betelgeuse, it could strip away material or induce instabilities that lead to events exactly like the Great Dimming of 2019. Understanding the profound influence of Betelgeuse B is now a crucial piece of the puzzle. It forces astronomers to reevaluate all previous models of the star's evolution and mass loss history. We can no longer look at Betelgeuse in isolation. We must view it as a dynamic binary system. Despite these exciting discoveries and the added complexity of a companion star, the ultimate fate of Betelgeuse remains unchanged. It is a dying star, and its death will be violent. It will explode. But, as the data currently shows, it is not going to explode tomorrow. Astronomers estimate that the supernova could happen any time within the next 100,000 years. In cosmic terms, that is the blink of an eye. In human terms, it means we might be waiting a very long while for the grand finale to finally light up our skies. However, the unpredictability is part of the thrill. We cannot pinpoint the exact date of the core collapse. It is a cosmic toss-up that could happen next week or in 50 millennia. The tension lies in knowing that the fuse has been lit, but the length of the fuse remains unknown. But we are ready for it. Scientists have deployed a global network of neutrino detectors buried deep underground in abandoned mines and under the thick ice of Antarctica. These highly sensitive instruments are waiting patiently in the dark, listening for the first whispers of a stellar death. These detectors are waiting for the silent, ghostly messengers of a supernova. Neutrinos are subatomic particles produced in staggering quantities during the core collapse. They are the immediate byproduct of protons and electrons being crushed together into neutrons at the very center of the dying star. Because they interact so weakly with normal matter, neutrinos will escape the collapsing star immediately. They will travel across the galaxy at nearly the speed of light, arriving at Earth several hours before the brilliant visible light of the explosion ever breaks the surface of the star. This neutrino burst will serve as our ultimate early warning system. When the detectors light up simultaneously with a sudden influx of neutrinos from the direction of Orion, we will know the end has finally come. The alarm will sound across the global astronomical community. Astronomers will have a few precious hours to point every available telescope, satellite, and scientific instrument toward Betelgeuse before the shockwave breaks the surface. It will be a mad dash to capture the very first moments of the supernova, a crucial window into the mechanics of stellar death. When the visible explosion finally reaches Earth, it will be a sight to behold. The supernova will rapidly brighten over several days, fundamentally transforming the familiar night sky. A new, overwhelmingly bright star will appear where the red shoulder of the Hunter used to be. At its peak, the exploding Betelgeuse is expected to be incredibly bright, potentially rivaling the brightness of a half-moon. It will be the brightest supernova observed by humanity since the invention of the telescope, offering an unparalleled view of a cosmic catastrophe. It will cast sharp shadows on the ground at night. It will be so brilliant that it will be easily visible during the day, a bright beacon shining in the blue sky. For a brief period, Earth will have a second, albeit much smaller and temporary, sun in its sky. This spectacular celestial show will last for months. Slowly, over a year or more, the supernova will fade, eventually disappearing entirely from the naked eye. The brilliant beacon will dim to a faint spark, and then vanish, leaving behind only a rapidly expanding cloud of gas and dust. Orion the Hunter will forever lose his glowing red shoulder. The constellation, familiar to humanity since the dawn of civilization and deeply ingrained in cultures around the world, will be permanently changed. A piece of our shared cultural heritage will be erased from the heavens. But while the star is dying a violent death, we are perfectly safe. Earth is located roughly 400 to 650 light-years away from Betelgeuse. This vast expanse of empty space is our ultimate shield against the fury of the exploding supergiant. This immense distance is more than enough to protect us from the deadly high-energy radiation and cosmic rays produced by the supernova. If Betelgeuse were closer, say within 50 light-years, the radiation could strip away our ozone layer, but at its current distance it is completely harmless. The blast wave and the expanding shell of radioactive material will dissipate long before they reach the outer edges of our solar system. For us, the death of Betelgeuse will be a purely visual spectacle, a scientific bonanza, and a profound source of wonder and inspiration. It will be an unprecedented opportunity to study a supernova in our own galactic neighborhood, in extreme detail, with modern sophisticated instruments. We will gather more data in a few days than we have from all other observed supernovae combined, revolutionizing our understanding of these events. We will learn intricate details about the final stages of stellar evolution, the complex mechanics of core collapse, and the creation of heavy elements. We will watch in real time as the inner workings of a star are laid bare for all of humanity to see and analyze. Because it is in the intense, unimaginably hot fires of supernovae like this one that the heavy elements are forged. The iron in our blood, the calcium in our bones, the gold in our jewelry, all of it was created in the dying gasps of massive stars long ago. The death of Betelgeuse will seed the surrounding interstellar medium with these newly forged elements, enriching the galaxy. This expanding cloud of stardust will provide the essential raw materials for future generations of stars, planets, and perhaps, one day, entirely new forms of life. In a very real sense, we are witnessing the great cosmic cycle of life and death, of destruction and creation. From the violent end of one star comes the potential for countless new beginnings. The universe recycles its matter in the most spectacular and dramatic ways possible. So, while we wait for the inevitable explosion, we continue to watch. We relentlessly monitor its brightness, we meticulously study its spectrum, and we look closely for the subtle, telltale influences of its newly discovered companion star, Betelgeuse B. The observation never stops. Betelgeuse remains one of the most compelling and heavily studied objects in the night sky. It stands as a stark reminder of the immense scale, power, and dynamic nature of the universe we inhabit. It teaches us that the heavens are not static, but constantly changing. Every fluctuation, every period of dimming, every unexpected brightening is a valuable clue to the internal workings of this stellar behemoth. We are slowly piecing together the life story of a supergiant, reading the chapters written in plasma, gravity, and light, across the vastness of space. The great dimming of 2019 taught us a vital lesson, that these massive stars can undergo rapid, dramatic, and highly visible changes on human timescales. It showed us that we don't have to wait millions of years to see stellar evolution in action. It happens right before our eyes. The discovery of Betelgeuse B in 2026 reminded us that even the most familiar and closely watched stars can still hide profound secrets. It proved that the universe always has the capacity to surprise us, challenging our established theories and demanding continuous exploration. As we gaze up at Orion, we are looking at a star living on borrowed time, a star that has already written its final chapter, even if the light of that ending hasn't reached us yet. We are looking at a ghost, a magnificent entity whose doom is already sealed. Whether it explodes in our lifetimes or thousands of years from now, Betelgeuse has already secured its place in the annals of astronomy. It has inspired generations of scientists, artists, and dreamers to look up and wonder about our place in the grand cosmic scheme. It is the monster star that captivated the world, the giant that taught us to always expect the unexpected. It is a brilliant laboratory for extreme physics, a place where the fundamental forces of nature battle for supremacy on a scale we can barely comprehend. It is a symbol of our enduring quest to understand the cosmos, to unravel the deep mysteries of the stars, and to trace our own biological and chemical origins back to the stellar furnaces of the distant past. It connects us intimately to the universe. So the next time you step outside on a clear, freezing winter night, take a moment to look up at the bright red jewel marking the shoulder of Orion. Take a long moment to appreciate its steady glow and ponder the incredible forces raging within it. Because one day, perhaps very soon, or perhaps not for 100 millennia, that red glow will suddenly become a blinding flash of white light. It will be a spectacular, terrifying, and beautiful grand finale for a truly legendary star. A cosmic fireworks display just for us. Until that day arrives, Betelgeuse continues its complex cosmic dance, a magnificent, volatile, and endlessly fascinating neighbor in the vast, cold emptiness of space. A shining reminder of the beauty and violence of the universe we call home.
If you enjoy this content and want to see more, please consider subscribing. A quick tap on the like button also helps us learn what topics you like best. Thank you for watching this video, and see you in the next one.